Next, we are moving on to page 5. We are reviewing both radical and exponents. The first one of the strategies we can try is to convert this to a radical form. Remember we say like for our power, this is your root number. So your root number is 2, and then you can do the square root first and then cube the answer. Inside we have 9 over 16, so it happened to be like both 9 and 16 can take square root easily. Square root of 9 is going to be 3, right? And then square root of 16 is going to be 4. So after we take the square root, the number gets smaller, and then we can do the cube after that. So 3 cubed means 3 times 3 times 3. That will give us 27, and at the bottom we have 4 times 4 times 4, so it's 16 times 4. It's going to be 64. Are we okay? So this means you can either like do the cube part first and then take square root, or you can do the square root first and then do the cube. So both of them would be fine. In our situation, it's easier to take the square root and then cube after that. Alright, the next one is the same base multiplying, so we need to do what? Add the exponents. Very good. So it's going to be x 27 adding a negative 17, right? So essentially that means subtract. So if we have x 27 minus 17, because they have the same denominator, so all we need to do is subtract the top, right? Kind of like x2 minus 1 over 7. So the final answer will be x raised to 17. Okay, the next one would be same base dividing, right? So we need to do what to the exponents? We're going to subtract. So 5, 9 subtracting a negative 2. So if I match them to be both a fraction, that would be 5, 9, negative times negative become positive. And then we have 2 over 1. And when we add and subtract fraction, we need the same denominator, right? So the LCD here look like it's going to be 9. So if I want to change the second fraction to have 9 as my denominator, both top and bottom need to multiply by 9, like that. So after that, we are going to have y 5 over 9 adding 2 times 9 is 18 over 9. And notice if we reduce it, it becomes 2 again, right? So when you have the same denominator, all I need to do is adding the top part. So 5 plus 18 is going to give me 23 over 9. Are we okay? So if it's a positive exponent, we can write that as answer, right? Okay, number 12, I want you to pay attention. Both of them have a root. Both of them have negative inside the root. The top one, I don't see a number here that has an understood 2 there. That's a square root. And the second one have a cube root with negative. So hopefully you remember from classes you took before. If you have a negative under a square root, that is going to turn into I, which is imaginary number, but this is only for square root only. So anytime if you see negative number under a square root, it will come out as I. And the next one is cube root, but so if you see negative number under the cube root, that means your answer is going to be a negative answer. Okay, so these are some of the things that you need to have the prerequisite skills to do something like that. We're going to try to review this quickly for you. So the first one is negative under square root, so it's going to come out as I. And then after you put that out, you still have square root of 4, right? Square root of 4 is going to be 2. 2 times 2 is 4, right? So the answer would be 2I. Are we okay? And the next one, it's going to be a negative answer, right? So some people will put a negative and do cube root of 27. Essentially what that means is, because this can be -3 times a -3 times a -3, and for keyword you need 3 as a group to get out, right? Which means your answer is -3. So you can think of this as like when you have a keyword with negative inside, you can pull a negative out. Inside you have 27, and keyword of 27 is 3, right? So it's like negative keyword of 3 times 3 times 3. So you should also get -3 as your answer, okay? All right, hopefully that's fine. Number 13 and 14 are simplifying radical. So again, the first one, number 13, has no root number, so it's understood as a square root. So if you don't see a root number, it means square root. When you have a square root, it means how many as a group do you need to get out? Because the root is 2, so it's 2 as a group to get out. 120 is a pretty big number, so if you cannot tell by just looking at it, you can break it down as factor using a factor tree. This is even number, so for sure you can divide by 2. 2 times 6 is 12, and then 0. 60 times 2 is 120. And this would be 2 times 30, 2 times 15, 3 times 5, right? You can stop once all the number are prime number, meaning they can only be divided by 1 and itself. So 120 can be broken down as 2 times 2 times 2 times 3 times 5, and I have a cubed, so I have b to the 4, 1, 2, 3, 4, and I need 2 as a group to get out, right? So this will give me one group of 2, so I can get that out as just 2. I have one group of a, right? Get out as a, one group of b, another group of b, like that. So inside, I still have a few items, right? Inside the square root, I still have this few items. So I'm going to write that out. It's going to be a square root of 2 times 3 times 5, and then one more a, right? So the final answer would be multiply all of them together. I have 2 and a, b to the second. Inside, I am going to have 2 times 5 is 10, times 3 is 38. Is that okay? And if you want to double check, you can think of this as 2 squared is 4, 4 times 30 is 120, a square, and then one more is 3, b squared, and square root, so it's going to be 4. Okay, so you can actually kind of double check your answer. Hopefully that makes sense. The next one is a keyword. So with a root number of 3, mean I need 3 as a group to get out. I can break the 81 on the side. So 81 can be broken down as 9 times 9, right? And then 3 times 3, 3 times 3. And we can stop once all of those numbers are prime numbers. So don't forget to put the little root number on the side. And then we can break that as 3 times 3 times 3 times 3. I have x, x, y, 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 y. And I need how many as a group? This time I need 3 as a group. So I have one group of 3. Get out as just 1, 3. I have one group of y and other group of y, right? That will give me inside still have a 3x and x, right? So if I just put a root like that and say 3 times x, that's not correct because I didn't put keyword, right? And that changed it to a square root and the x can get out, right? So don't forget, you need a little root number here. Final answer, we just need to multiply them together, right? So we're going to have 3 and then y to the second power and then cube root of 3 times x to the second power. Is that okay? And don't forget the cube root. So we can double check still. 3 cubed is 27. 27 times 3 should be 81. And then this is 2 times 3 is 6. So y to the 6, and inside you have x squared. Okay, so you can double check that. Okay, next we are going to review some of the property with log. If you just took college algebra or business math, we have talked about this. This property of log is really much related to the exponent rule, because log is another way to express exponents. It's the inverse of it. So similar rule, when you see same base multiplying, we are going to break that as addition. When you see same base dividing, we are going to break them as subtraction, just like the exponent rule. And then if you see an exponent here, it's going to turn into coefficient, go to the front, like here. So addition turn into multiplication, division turn into subtraction, exponents turn into coefficients. So the first one will be, break it into two terms. Both of them come with log base a plus log base a. Multiplication turn into addition. The first term come with m, second term come with n. And don't forget to write down the base, okay? The second one, division turn into subtraction. So again, this one come with two terms. Division turn into subtraction. First term come with m on top, last term come with n at the bottom, okay? And then exponents will turn into coefficient to the front, and then just write down log base a m. Are we okay? So the ln with natural log is going to be using the same rule as the regular log. So if you want to pause the video and try that, multiplication turn into what, division turn into what, exponents turn into what, you can write that down and check with my answer, okay? We are ready. Again, this is multiplication. It's going to turn into addition. Two terms. First term is ln with the u. Second term is ln with the v. Second one is division turn into subtraction. So we're going to have ln u minus ln v. And then the last one, the exponent, is going to turn into coefficient. So the v go first. And then we have ln of u. All right. So those are the basic rules. And the next two questions, we want you to expand this log to sum and differences. So this one look like you have three terms, 1, 2, 3 here, right? And then multiplying together, so we're going to need to expand them as multiplication turn into addition, right? So three terms, so all of them come with the same base of log. First one come with 8, and then second one come with x cubed, and the last one is y squared. I think I need to also remind you one of the log property, which is log base a, ax. If they match, you can kind of cancel it, equal to x. So if you have log base a, and then a here, they match, it kind of cancel, equal to x. So we did that in 1324, the first business math class. So don't forget, when you see exponents, that's going to turn into your coefficient. So these three go into the term, the beginning of the same term, these two go here. And this one, there is a way for me to do log base 2 and 2 to some power, because I can then apply this property, right? So if you haven't done log for a long time, we may need to review that with you a little bit. So feel free to come see me after class. We can work on that. 8 is 2 to what power? So 8 can be 2 times 4 and 2 times 2, right? So it's 2 times 2 times 2. So it's basically 2 to the third power. And then we have my exponents here. We have the exponents here. This is log base 2x. And this is log base 2y. So we can kind of cancel this one. This becomes 3 plus 3 log base 2x plus 2 log base 2y. Are we okay? Alright, so the last one is division. Division can turn into subtraction. But you have to be careful. This look like 2 terms here. So let's just break the division part first. If we have ln of 3x subtracting ln of square root x. So first of all, the square root can turn into some exponents. Hopefully you remember it's going to be x raised to a fraction exponents. This is 1 here, this is 2 here, right? So your root number is 2 and the power is 1, right? And then also this is 2 terms multiplying together, so I can break that as addition. Multiplication become addition. So this is ln of 3 plus ln of x, subtracting that. So final part is that we have exponents will turn into coefficient here. So we're going to have ln 3 plus ln x minus 1/2 ln of x. So again, like if you haven't done log for a while, you may need to spend a little bit time reviewing that. I know we're supposed to just do page 5 here, but I see the coordinator assigned one question with the E. So let's flip it to the next page, use this blank space and review a little bit, okay? So E is a natural number. If you put it on your calculator, it will give you a number just like pi. If you go use your calculator, and then I have an E which is y on top of ln, they're related. So I'm going to do an E to the first power. It's going to be a non-terminating decimal number. So if I do E to the first power is 2.7182, and then this number will go on forever. So E is natural number. And it equal to 2.718. Keep going. If you see a log base E, that's going to be the same as ln. And remember we say log base ax equal to x, right? So if you have log base E is ln, and you see ln of E, that would be ln can be replaced with log base E, right? And then you have one more E here, like that, it can cancel. So essentially ln E actually just equal to 1. So that's another thing you may need to know. There is a homework question look kind of like this. Ask you to solve for x. If e to the x equal to 2.116. So they are trying to use the fact that ln e kind of cancel equal to 1. So they said raise both sides with ln and then can't use calculator. So the strategy is raise both sides with ln and then use calculator. So ln on the left, ln on the right, and then you have e to the x here. So this part is 1, so it's going to be x equal to ln of 2.116. So we're going to need to use the calculator and do ln of 2.116, close it, and hit enter. Your homework asks you to do 4 decimal places, so x will equal to 0.74 95. Okay, so you may have a homework question ask you to do something like this. Give you a question, e to the x raised to that, raise both sides with ln. ln and e kind of cancel each other, equal to 1. So x will equal to, use your calculator, ln, plug in that. Okay, so one homework question may look like that. So I want to show you a real quick example. All right.